You have 845 decorative bricks delivered to your house and set down in your driveway. You need to move all the bricks to your backyard. You move a few bricks by hand and quickly decide that will take forever, so you go buy a wheelbarrow to haul the rest. You decide to pace yourself by hauling 5 wheelbarrows full of bricks each hour. After 4 hours, you determine you have moved 245 bricks to the backyard. After 7 hours, you have moved 425 bricks to the backyard. The first question is, how many bricks an hour are you moving using the wheelbarrow? And this value is actually the slope of our linear equation, where if we have a linear equation in slope-intercept form, it fits the form y equals mx plus b, where m is the slope, which is the constant rate of change, or in this case, the number of bricks moved per hour. B is the vertical intercept, or the value when the initial input, or in this case x, is equal to 0. So going back to the given information, first thing to notice is because we're concerned about the number of bricks per hour, we really don't care that you're hauling 5 wheelbarrows full of bricks per hour. We only care that after 4 hours, you determine 245 bricks have been moved, and after 7 hours, you determine 425 bricks have been moved. Let's first put this information in ordered pairs. So the first point would be 4, 245, because after 4 hours, 245 bricks have been moved, or we can say when the input is 4 hours, the output is 245 bricks moved, and after 7 hours, 425 bricks have been moved, so the second ordered pair would be 7, 425. Now for this problem, we're going to be finding a linear function in the form of q of t, so we can say the input would be t, the first coordinate, and the output would be q of t, the quantity of bricks moved. Now that we have the two ordered pairs, we can find the slope, or the number of bricks moved per hour using the wheelbarrow, by determining the change in the function value divided by the change in the input, or in our case, we would have the slope equals the change in q, or q of t, divided by the change of t. So for the change of q, we'd have 425 minus 245, and for the change of t, we'd have 7 minus 4, so we have 180 divided by 3, which equals 60, which means you're moving 60 bricks per hour using the wheelbarrow. So your answer would be, I am moving 60 bricks an hour using the wheelbarrow. And again, let's go ahead and record over here that we have m, the slope, equals 60, or if we want 60 bricks per hour. Now the second question asks, how many bricks had you moved by hand before you started using the wheelbarrow? This value is actually going to be the vertical intercept, often known as the y-intercept, of our linear equation. We'll find this algebraically in the next part, but let's try to find it logically. If we now know that you're moving 60 bricks per hour, and after 4 hours you've moved 245 bricks, we can use this information to work backwards to determine how many bricks you moved at the start, which would be at 0 hours. So we'll go ahead and use this first point. We could use the second one, but let's go ahead and use the first one. And the fact that we know the slope is equal to 60. So if we wanted to determine how many bricks you had moved at 3 hours, we'd have to subtract 60 one time. If we wanted to determine how many bricks you had moved after 2 hours, we'd have to subtract 60 two times, and so on. So if our goal is to determine the number of bricks moved when time equals 0, or before you started using the wheelbarrow, we could take the amount moved at 4 hours, 245, and subtract 4 times 60 to determine how many bricks moved at time 0. Again, we're subtracting 4 times 60 because 245 bricks are moved after 4 hours. We want to know how many were moved after 0 hours. So we have to subtract 4 60s. So this would be 245 minus 240, which equals 5. So your answer would be, I moved 5 bricks by hand before I started using the wheelbarrow. Now the next part asks us to write the linear equation that represents the situation we're asked to write the equation in the form of Q of t equals mt plus b, where we already know Q of t is the quantity of bricks moved after t hours using the wheelbarrow. Well, we already know that m, the slope, is equal to 60, and we actually already know the vertical intercept is 5, but let's just assume we didn't know the vertical intercept was 5. We can set this up as Q of t equals 60t plus b, and now we could use one of our points to determine the value of b. Again, remember the first coordinate is t and the second coordinate is Q of t. We could use either point, but to see the connection from the previous part, let's use this first point again. So we'll substitute 245 for Q of t and 4 for t. So we'd have 245 equals 60 times 4 plus b. This looks very similar to the last part. We have 245 equals 240 plus b, subtracting 240 on both sides. We can see the vertical intercept is 5. So if we know the slope equals 60 and the vertical intercept equals 5, we'd have Q of t equals 60t plus 5. And now for the last part, we want to find the value of t, or how many hours it's going to take until Q of t, the quantity of bricks, equals 845. Remember, this is the total number of bricks that you had delivered. So what we'll do is, using a linear equation here, we'll substitute 845 for Q of t and solve for t. So we'd have 845 equals 60t plus 5. Subtract 5 on both sides. That would give us 840 equals 60t. Divide both sides by 60. So we have t equals 14. Remember, this would be in hours. We're asked to write our answer as an ordered pair. So the ordered pair would be open parenthesis, t, which is 14, comma Q of 14, which is 845. Remember, as an ordered pair, the input is always first and the output is always second, or in this case, t is first and Q of t is second. And now we're asked to complete the following sentence. After using the wheelbarrow for 14 hours, I will have moved all of the bricks to the backyard. I hope you found this helpful.